My name is Robin Whitted. I would like to thank everyone for joining us this Wednesday morning. It's finally not raining, at least not here in Frankfurt, it isn't. This is our first webinar in a series all about carbon footprint. If I can speak, this will be a very better day, won't it? Carbon footprint reduction. So today we are literally just going to be going over the basics of what is a carbon footprint and the basics of how to reduce one's carbon footprint. Before we get started, I'd like to go over some just general housekeeping things. Attendees, you will be in listen only mode. So if you have a question or a comment, please use the chat feature. We are monitoring that. If your camera is not already off, please make sure it is off. The co-hosts or the speakers, please remember to keep muted and turn off your cameras until it is your time to speak. And while I'm here, I want to actually introduce someone who is helping us behind the scenes. You will hear her voice randomly throughout the day, and we could not do this without her. This is Lindsay Hirsch. Lindsay, you want to say hello to everyone?
Hi everyone, I'm Lindsay. I'll be your tech help for the day. So if you are having trouble, if something is acting up, you can shoot me a private message in the chat and we'll hopefully be able to get it fixed for you.
Thanks, Lindsay. Lindsay's also going to be helping us do polls throughout the presentations. So she'll be reading them and doing all the behind the work for that, okay? So once again, thank you, Lindsay. You're amazing. Now, for those of you that are not familiar with Kentucky Excel or the Division of Compliance Assistance for that matter, the division is one of the 5 public-facing divisions in the Kentucky Department for Environmental Protection. Most people are familiar with the Division for Air Quality, Waste Management, Water. There's even a few people familiar with the Division of Enforcement. Those ones are pretty self-explanatory. The Division of Compliance Assistance, we're one of the smallest divisions, and our objectives is to certify qualified environmental professionals, help entities comply with Kentucky's environmental requirements, and to facilitate environmental leadership. We do this through our 2 different branches, certification and licensing branch, and the environmental assistance branch. Between these 2 branches, we have 4 different programs. The first one I'm going to talk about is the operator certification program. They're the ones that certify your drinking water operators, your landfill operators, your compost operators, a variety of different operators throughout the Commonwealth. You also have in our division, the Brownfield Redevelopment Program. The grants and outreach portion of this program is housed in the Division of Compliance Assistance. There's also a section of it that is housed in the Division of Waste Management. Also within DCA, we have the Compliance Assistance or the Environmental Compliance Assistance Program. I commonly call this ECAP, and they do a multimedia approach of helping everyone out with waste management questions, air quality questions, and even water quality, specifically related to permitting and regulatory. Kentucky Excel is the program that I coordinate. It is the state's free environmental leadership program that encourages its members to complete voluntary projects that improve the environment, like reducing one's carbon footprint. Now, when I say environmental projects, these are environmental projects that are voluntary, and the members get to tailor their projects and pick their projects every year. The key requirements for being a member for these projects is that they must positively impact the environment and, like I said, be voluntary. So in other words, not required by any law or regulation. Now, every year, the members submit us reports about how they're doing with their projects. And over the years, they have actually conserved enough water to fill over 100 Olympic-sized pools and power over 13,000 Kentucky homes for 1 year. They have also recycled enough aluminum to make more than 6 million soda cans and enough still to make, what does it say on there? quite a few compact cars. Let's just put it that way. They've also prevented tons, literally tons of emissions. And this is a variety of different air emissions. And they've saved a few $billions, I would say, enough that they could put almost 2 million undergrad college students all the way through 4 years of public college, tuition, fees, room and board, all paid for. They've also trained and educated through that outreach and environmental education efforts a few individuals throughout the Commonwealth, whether it be students, employees, or just the general public. Now, their projects range from being locally involved to being globally involved. For example, a lot of times they'll do a river pickup. So that will clean up the water locally, but also prevent pollution from drifting downstream and eventually collecting possibly in like the Gulf of Mexico. There's also one partner in which they would collect soap. They were a hotel. So they would collect all the unused soap from all their hotel rooms and send that soap to be reused overseas in third world countries. Kentucky Excel, it's a community of people doing good deeds throughout the Commonwealth. There are different types of membership. For those regulated by the Department for Environmental Protection, it's a tiered membership. So we start with a partner, which is one project per year. They have to develop an environmental management plan within their first year and also do a self-assessment. For leaders, it bumps up to 3 projects per year. Once again, they'll have to do the self-assessment and they have to have their environmental management plan implemented within their first year of membership. For masters, it is 5 projects per year, one of which has to be outreach or education in nature. They have to pass a compliance history check. So make sure that they have not had any regulatory issues related to the environment over the past 3 years. They also have to have an implemented environmental management plan and complete a performance assessment from a third party, not a self-assessment, but a third party self-assessment. For those not regulated by the department, there's an advocate membership, which is 1 project per year, or even farms. Once again, 1 project per year. They have to be 5 acres or more and raise crops or critters. In order to join Kentucky Excel, it's pretty simple. Just complete an application form and send it to me. The only other times other than joining, if an application is required, is when they want to change membership types or levels or upgrade their membership level. Membership is annual. So to renew, they have to submit a project proposal and a project report for their previous projects. The benefits of being a Kentucky Excel member, you get to use the Kentucky Excel logo for marketing. We also can do member spotlights on a member if they would like. With non-COVID times, we would do a lot of workshops, and field trips. We even have an annual event called the Kentucky Celebration, where we go through and we present awards for Kentucky Excel Beacon Awards. These awards are based off of the Kentucky Excel members' projects, and there's 6 different types of them. Those are annually presented at the Kentucky Celebration. With COVID times, we are adapting, so we are doing more webinars and virtual events. We also have a lot of recognition opportunities. So we use our social media outlets within the cabinet and newsletters and things like that to recognize the Kentucky Excel members. We also have award opportunities. Like I said, the Kentucky Excel Beacon Awards is one such award opportunity. There's also one from the department itself. Every year, the Department for Environmental Protection presents 4 Environmental Excellence Awards at the Governor's Conference in October. One of these is specifically for Kentucky Excel members. That's the Kentucky Excel Champion Award. These are public nominations So if you would like, we are actually accepting nominations right now for all 4 of the different awards given at the Governor's Conference from the Department of Environmental Protection. And if you have any questions about DCA or Kentucky Excel, or even the Environmental Excellence Awards that will be presented at the Governor's Conference this year, just shoot us a quick email. And here's our contact information. Now, let's move on to why you guys are here. Learning about carbon footprints. But before I start my presentation, just explaining the basics of what is a carbon footprint, I'm going to give you 2 questions. You don't have to know the answer, but just guess to your best ability, okay? Lindsay, you want to read that for us?
Of course. So our first question is, what is the most abundant anthropogenic greenhouse gas? Your choices are water vapor, carbon dioxide, nitrous oxide, or methane.
All right, we got about 50% of everyone's answered, so we'll give a few more seconds, a minute total, get everyone's answers in. And like I said, if you don't know the answer, just take a good guess. All right, Lindsay, you want to move on to the next one?
Your next question is, which greenhouse gas listed below has the highest global warming potential? And again, your chances are carbon dioxide, methane, nitrous oxide, or fluorinated gases.
And once again, we'll give a full minute. I think I cut you off at 5 seconds early. We have 6 people that have answered. And you will be asked the same questions after the presentation. So if you don't know the answer now, hopefully you'll learn throughout the presentation. If not, send me an email and you can tell me to work on my skills. All righty, that's our 2 questions. And I'm just going to start on up as soon as Lindsay finishes the poll. You want to go ahead and close that out, Miss Lindsay? Let's not share results just yet.
You're good to go, Robin.
Thank you, Lindsay. All right, I'm not sure about you guys, but it seems like nowadays, everywhere I turn, people are talking about footprints, especially over the past 10, maybe 15 years. And it's kind of confusing because it's a footprint here, a footprint there. And I did wildlife work for a while there. So there were all types of footprints out there, usually tracks. But when we say the term footprint, normally nowadays we're talking about 1 or 2 types of footprints. You have your ecological footprint, which is the measure of human impact on Earth's ecosystems. Normally this is measured in like natural resources used or land use, something like that. And as you can see along the screen here, your ecological footprint includes the fishing grounds, the lands that's been developed, your grazing lands, your crop lands, and even your forestry land. But in the middle, or closer to the hill there, you see there's another footprint included within one's ecological footprint. That's your carbon footprint. Carbon footprint is the total set of greenhouse gas emissions created by an individual, event, organization, or product. Now, this is equivalent to your carbon dioxide It is expressed as a carbon dioxide equivalent. And as you can see, there's a variety of different ways in which one can emit greenhouse gases in their daily lives. We've got transportation, just the generation of electricity, emissions of greenhouse gases themselves, fuel, burning of gas, and even your recycling or disposing of waste create greenhouse gas emissions. Now on the screen here is sources of human-caused greenhouse gases. On the left, we have a pie chart with the percentage of how much each economic sector, now this is from 2019, in the US produced greenhouse gases. So transportation in the US pre-COVID was the highest source of greenhouse gases in the US, followed then by electricity generation or in industry. If you look on your right, there's another colorful pie chart, and it's the same information, but instead of just the US, this is globally. So according to this pie chart, once again, pre-COVID 2019, electricity and heat production was the biggest source of greenhouse gas emissions globally. And then it was followed closely with 24% agriculture, forestry, and other land use. Now there are 5 major greenhouse gases. There's carbon dioxide, methane, nitrous oxide, and fluorinated gases, and lastly, water vapor. Now each gas has a different impact on the greenhouse effect, and thus a different way of influencing global warming or climate change. One of these is just the concentration. How much of it exists in the atmosphere? This is often measured in parts per million or parts per billion or even parts per trillion. You also have the lifetime of that gas. So how long does it remain in the atmosphere? And lastly, the global warming potential of the gas. So how effective is it at trapping heat? Now this is a measure of the total energy that a gas absorbs over a 100-year period relative to 1 ton of carbon dioxide. Therefore, carbon dioxide's global warming potential is 1. And the lifespan of carbon dioxide in the atmosphere ranges from 100 years to 10,000 years. And as you know, it is created by natural sources, the carbon cycle, and also through human activities, most commonly the combustion of fossil fuels. Now, roughly 75% of all global human-caused greenhouse gas emissions is carbon dioxide. That is why it is the most important anthropogenic or human-caused greenhouse gas. And right now, a lot of people are trying to decarbonize or reduce their carbon dioxide emissions. And the goal of decarbonization is to create a carbon dioxide free global economy. Now, methane doesn't stay in the atmosphere as long as carbon dioxide. It stays in the atmosphere roughly 10 years, but it does have a higher global warming potential, a 25. And about 16% of all human-generated greenhouse gas emissions is methane. Naturally, it is created from wetlands and termite mounds, and human activities, it ranges from coal mining, natural gas production, distribution, to waste just decomposing in the landfills, to even just the digestive processes of livestock in agriculture situations. Nitrous oxide stays in the atmosphere roughly 100 years, and its global warming potential is 300, less than carbon dioxide or methane. Around 6% of all human-generated greenhouse gas emissions is nitrous oxide. Once again, naturally, similar to methane, it is created from wetlands and termite mounds, which I'm not sure if we have too many termite mounds here in the US, but you are welcome to correct me on that one. You also have human activities like agriculture, industrial activities, and also just the burning of solid waste or fossil fuels. Fluorinated gases. There are no natural sources of fluorinated gases. The reason being is they are man-made gases. And there's 4 different main categories of fluorinated gases. Now, they can stay in the atmosphere around 10,000 years, if not longer. Their global warming potential ranges from 1,000 to 10,000. And roughly 2% of all human-generated greenhouse gas emissions are fluorinated gases. And like I said, there are no natural causes or sources of fluorinated gases. So all the emission sources are human activity based. Water vapor is an interesting greenhouse gas because it is the most abundant of all greenhouse gas. And a lot of it is just natural water being released into the atmosphere. And for example, warming that results from other emitted greenhouse gases can increase water vapor. So there's this positive feedback loop that actually leaves a lot of uncertainty as to the impact of water vapor on the greenhouse effect and climate change. Now, I've gone through real quickly what a carbon footprint is in the 5 most common greenhouse gas emissions included in one's carbon footprint. So to help you get a better idea, I'm going to do a case study, but I'm going to go ahead and apologize up front because the entity that we are doing a case study on is highly controversial, which is one of the reasons I picked this entity, because due to it being controversial, pretty much everyone is aware of them, okay? So once again, I am sorry if I'm offended, but it's a wonderful example, okay? Santa Claus. For those of you who are not familiar with Santa Claus, he is a Scandinavian-based tradition, and he goes around the world once a year delivering toys to all the good boys and girls. And then he does this using a sleigh and reindeer. And throughout the year, he produces all these toys that he delivers. All right. With his reindeer, which I would have to sing Rudolph the Red-Nosed Reindeer to remember how many reindeer there are. But through those reindeer, Santa Claus's one trip will emit over 400,000 metric tons of carbon dioxide. And remember, there will also be a production of methane just due to the digestion of the critters, all right? Santa not only delivers toys to good girls and boys, but he delivers lumps of coal to the bad boys and girls, all right? So let's say each lump of coal that Santa leaves behind is roughly 6 ounces, and about 1/5 of the children on Santa's list is naughty. So that would mean that about 75,000 tons of coal is left in the stockings throughout the world on this one night. So through mining, that would mean about 30,000 metric tons of carbon dioxide is released. And then another nearly 200,000 would be released if people burned all the coal that was delivered. When it comes to the life cycle of Santa's toys, we are going to talk about just the initial production, the assembly, packaging, and disposal. Just kind of keep it simple. And through that, it's about 68 million metric tons of CO2. And people always leave milk and cookies out for Santa to eat. So per 1 kilogram of food produced, it ranges, so the milk and cookies produced and left behind, it ranges between 750 to 900 grams of CO2 emissions released, okay? As we know, Santa's workshop is top secret, so we do not actually know how large of a facility it is. So we're going to guess it's just the equivalent of a large toy factory, okay? And about 900,000 metric tons of carbon dioxide is released from the operations, so like the energy used by this facility, okay? Now, wrapping paper is different than toy packaging. Toy packaging is actually like the plastic little packaging that comes in, or the cardboard box that makes it easy to put the wrapping paper on. So by wrapping each one of the one presents that every child receives, there will be more than 250,000 metric tons of carbon dioxide released. So if you look at Santa's carbon footprint, the biggest source of carbon is actually the life cycle of making the toys, okay? So if Santa wanted to reduce his carbon footprint, that would be a great place to start. If you wanted to calculate your own carbon footprint, you can. You can do it by using emission factors and whatnot, or even using some already existing carbon footprint calculators. One is through EPA, the Environmental Protection Agency. This one that you see on your screen, and if you would like to use it, the website's literally at the top here. But this one is designed for households. So it's a great way to know what your carbon footprint is. Or if you wanted to share it with peers or coworkers, just to make them aware of what their carbon footprint, or just for fun. If you are an entity that would like to calculate your carbon footprint, EPA has another calculator that you might find of use. This is the Greenhouse Gas Equivalencies calculator. Once again, the website's at the top here. And as you can see, you would enter your energy data and your emissions data into this, and it would help you calculate your greenhouse gas equivalencies. If you've done a baseline, there's actually a WARM tool, or a waste reduction model tool, in which one can use to help calculate how much of your carbon footprint you have reduced over the years, okay? Or just a matter of months. Now with that, I'm going to stop because our next presentation is actually all about baselining. But before we move on to Samantha Gordon from the Kentucky Pollution Prevention Center, we're going to do the same poll that you took earlier, okay? And we'll give you the answers. Lindsay?
All right, folks, again, the first question is, what is the most abundant of the anthropogenic greenhouse gases? Your selections are water vapor, carbon dioxide, nitrous oxide, or methane.
And the key wording here is anthropogenic, so that's created by humans.
All right, Robin, it looks like everyone has answered the question.
All righty, and Lindsay, if you move on, I think it does show the answer. And for those of you, it is that orange one, carbon dioxide. And we can move on to the next one.
Your second question is, which greenhouse gas listed below has the highest global warming potential? Again, your options are carbon dioxide, methane, nitrous oxide, or fluorinated gases. All right, Robin, that's everyone.
All right, the answer is, if Lindsay won, fluorinated gases. It ranges from 1,000 to 10,000, the global warming potential. Carbon dioxide's global warming potential is 1, and methane's is 25. So quite a bit larger than any of the others listed. Thank you guys for taking the time to listen. We're going to move right on into Samantha Gordon from the Kentucky Pollution Prevention Center. Samantha, you ready?
I am. Thank you, Robin. So while I start sharing my screen, we can go ahead and do my poll questions.
All right, folks, this question is how many scope or scopes of emission are there? 1, 2, 3, or 4? We'll give you about 20 more seconds to answer if you haven't already. All right, everyone has answered the question.
All righty, so if you don't know the answer, I will definitely be going over it a couple of times throughout my presentation and as to why. Oh, I have one more question.
And this question is, what scope does natural gas fall under? Scope 1, 2, 3, or 4? Again, we'll allow about 20 more seconds. All right, Samantha, you can go on ahead and get started.
Okay, awesome. So yeah, like they said, my name is Samantha Gordon and I am a senior sustainability engineer with KPPC. And today I'm going to be talking about baselining your carbon footprint. So I'm going to begin a little bit about what KPPC is if you're not familiar with us. So we are the Kentucky Pollution Prevention Center, and we are a university-based technical assistance program whose services are free, confidential, and non-regulatory. So we provide training and technical assistances to businesses and industry throughout the state of Kentucky, as well as organizations. We help improve efficiency through waste minimization, energy management, wastewater conservation, water conservation, those types of things. And it's also important to note, like I said, our services are free, also confidential and non-regulatory. So if we see something, you know, that's against regulation, we're not going to be sharing that with the state because we are very confidential. So today I'm going to be going over a few different things. So I'm going to talk about the GHG protocol, so where all this information comes from, scope 1, 2, and 3 emissions, emissions calculations, an EPA tool that will help you calculate your emissions, and there will be some time at the end built in for questions. Okay, so I'm going to be talking about, like I said, all of the different types of emissions, and you'll hear me talk a lot about rules and like little standards that you'll have to follow. And a lot of those all of them come from the WRI GHG protocol. So these are 3 main documents that I will be pulling from. So the first one is the corporate accounting and reporting standard. There's also an additional protocol for just scope 2 and another one for just scope 3. So if you ever have questions, you can go reference these documents, but that's where I'm pulling my information about a lot of these rules. So the first thing that you need to do to calculate your emissions footprint, your boundary, your inventory, is understanding where do you draw the line. So if you have multiple sites that you are calculating your emissions for, you need to understand like what is the boundary. So there's two schools of thought for this. The first one is financial control. So if you have financial control over an entity and you get that economic benefit, but you don't have operating control over it. The second one is operational control. So that means you can basically walk into a facility and say, I want that piece of machine moved and this other one plugged in. You know, you have full power over their operations. So if that's a little confusing, most of the time, probably 90% of the time, it's going to be operational control. Or if you only have one site, you really don't have to worry about this. You're automatically just going to be operational control. So the next thing is defining the emissions. So there are 3 scopes of emissions. So scope 1 is direct emissions from your facility or anything owned by the facility that may leave, so a company vehicle. Scope 2 is indirect, and most likely is going to be electric power, purchased electric power. And then scope 3 is pretty much everything else. So it's defined in upstream and downstream. That's why you can see there's 2 different arrows there. And you can see they're all pointing to the greenhouse gases that Robin talked about. So CO2, CH4, N2O, HFCs, PFCs, and SF6. So those are the most common ones. So I'm going to be diving into each one of these scopes and which emissions and activity categories fall under each of those. So we'll start with scope 1. So scope 1 is direct emissions, so anything that happens at your facility. So that's going to be any sort of purchased fuels, you know, that could be fuel oil, other types of fuels, coal, diesel, gasoline, but diesel and gasoline would need to be just from company-owned vehicles or anything that happens on site. So you would not include your employee commuting diesel and gasoline with scope 1 category unless the vehicle is owned by the company. Another one would be natural gas. This is the biggest scope 1 category because it has a very large footprint and most likely you're going to be consuming more natural gas than most other fuels. So this is the case for most of companies, but if you have a unique situation, obviously that's possible that it's not also. And then the last one is refrigerants. So if you have, you know, a cooling system and you have to recharge it, there's a leak, you're going to need to include those refrigerants under the scope 1 category. And like Robin talked about, refrigerants have a very high global warming potential. So their numbers are going to look super scary, but most likely a lot of refrigeration systems are a closed loop system. So the only time you really add to them is if there's a leak and you would want to get that fixed immediately. So scope 2 is indirect. And like I said, most of the time, this is just going to be purchased electric power. There are a couple of instances where you may purchase steam or chilled water from a centralized utility plant. Then you would include that also in scope 2, but that's only if you purchase it from an outside entity. If you create steam with a natural gas boiler, those emissions are included with natural gas in scope 1. Or if you have an electric chiller, those emissions would be already included in the electric power number already calculated within scope 2. So you would not want to double count those. So that's only if you produce those separately, or that's only if you purchase those separately. If you produce them on site, those are already included. The other thing that you would want to include with scope 2 is any renewable energy. If you have solar panels or any other type of renewable energy that you're potentially purchasing to offset your electric power usage. So there are 2 ways that you calculate scope 2 emissions. There is location-based and market-based. So location-based kind of puts everyone on the same playing field. So a kilowatt hour is a kilowatt hour, and you compare that, or you multiply that by your emission factor. That's just a grid average emission factor. So for the US, the EPA publishes EGrid. It's a data set. You type in your zip code and you get your emission factor. So that's what majority of people use in the United States. And that would be your location-based number. So you would also include your solar numbers if you had solar in addition to purchasing grid power, and it treats all of the kilowatt hours the same. The second way is market-based. So if you have, you know, your renewable energy, if you have a solar array, that's where you would include that as an offset for market-based number. The other thing with market-based is that if you know the power plant where you purchase your electricity from and they have their emissions data publicly available and a few other standards that's listed in the Greenhouse Gas Emissions Protocol, you can also use that specific emission factor from that. So, you know, if your power plant is predominantly nuclear power, you know, that has an emission factor of 0. So you could use 0 for that under the market-based calculation. So companies will publish both location and market-based if they have renewable energy or choose to use those different emission factors. So you would say scope 2 location-based number, scope 2 market-based number. You would not sum them together for your total emissions. Okay. So the next one, I've been talking a lot about renewable energy, so I want to make a point to talk about renewable energy credits. So a renewable energy credit, or a REC, represents 1 megawatt hour of renewable energy. So 1 REC can offset 1 megawatt hour of brown or grid power. And there are lots of standards on how these claims can be made that are, you know, legally binding. So one special thing about RECs is that they do not have to be grid connected to where the REC is being applied. So RECs are generated all throughout the United States, and you could purchase one in Texas to offset your power in Kentucky. So that's something that you can definitely do. It's not against the rules. Some NGOs do not agree with that. But you know, you could be in a place in Kentucky where it's not really financially advantageous or really just not possible to put in solar. Or wind, or whatever the renewable energy source you're looking at. So you would want to purchase REC. So that's one of your options for renewable energy. And then the last thing, only one entity is able to claim a REC. So if you are considering putting in a big solar array or any sort of renewable energy, you'll want to make sure that you are claiming those RECs, like that is part of the contract. Okay, moving on to scope 3, that's value supply chain. And there are 15 categories of scope 3. It's upstream, which is everything, including the product and above the product. And then downstream is after the product is manufactured, basically. So the most common scope 3 categories, I would say, are categories 5, 6, and 7. So waste generated in operations, business travel, and employee commuting. Those are probably the easiest to calculate. There are many different methods of calculating scope 3 emissions. So it's really hard to compare apples to apples for some of these. So Robin brought up the WARM model. That would be for scope, or for number 5 there, waste generated in operations. For business travel, most travel agencies that companies hire will have this number for you. So that's easy. And then employee commuting can be calculated based off of some sort of survey that you send out to your employees. The other ones, there's lots of different models that you can use, but you do not have to calculate all of these categories. In fact, some of them, like 14 and 15, are very difficult to quantify, and they're still kind of testing out different models and how to do that. So Robin talks a little bit about this, the global warming potential. So when calculating emissions, you need to know what the global warming potential is. So it's just a measurement of how much heat is trapped in the atmosphere for a specific time horizon relative to carbon dioxide. So it compares molecule of methane to how much heat it holds compared to carbon dioxide. So you can see they study this data over several years, and they release different reports according to their findings. So they're on the 5th assessment report right now. And I just listed the top 3 up there right now. So in terms of actually calculating emissions, how you get carbon dioxide equivalent, you take your consumption number times your emission factor times your global warming potential. So let's take 1,000 megawatt hours of electric power, for example. So I have 1,000 megawatt hours times my emission factor, which I pulled from the EPA EGrid, and then times the GWP. So for carbon dioxide, the GWP is 1, so you just take that. For CH4, you do 1,000 megawatt hours times my emission factor times my global warming potential of 28. So you repeat that for all the greenhouse gases that the emission factor is applicable for. So I just did CO2, CH4, and N2O. So you get those 3 numbers, and then to get CO2e, you just add all of those numbers together. So that's about 1.1 million pounds of carbon dioxide equivalent. Or another common unit of measure that you'll see a lot of companies, even within the United States, is metric tons. So that's also the same as 541 metric tons of carbon dioxide equivalent. Now, this is just electric power. If you had 7 other sources, that would be quite a bit. So I'm going to dive in how you should go about actually gathering your data and go calculate your inventory. So the general process that you want to follow for step one would be data gathering. So gather all your utility bills, your POs, whatever you need to get the information that I've covered previously to compile your inventory. The second thing is to write it down. Where did you get that data from? Who did you get it from? Did you make any estimations, or did you make any decisions about what to include and what not to include? The third step would be to calculate emissions based off of emission factors, and you would also want to document what emission factors you used. And then step 4 would be quality check. So, humans are involved with this process, so there are going to be some mistakes. I'm sure some of you have gotten a bill that is like outrageous, and the utility company made a mistake and had to credit you on the next bill. So you want to make sure that that is properly documented and your data is accurate, because maybe that didn't quite make it to the spreadsheet that you're using. So that's an example of a quality check. But you need to understand, where could things go wrong? Where could the data not tell the story that you were expecting? Okay. So we do not recommend that you calculate your emissions by hand. The EPA actually published a really great tool, the EPA Greenhouse Gas Emissions Calculator. So it's a simplified calculation tool that walks you through all of the scopes on an annualized basis. And this is for businesses and lower emitter organizations. So if you have like 100 sites, it's probably not the tool for you. I think it could be done, but it may be easier to use something else. So this is on an annual basis. So you would need to repeat this every year if you were going to use this tool each year. And it calculates both direct and indirect emissions, so scopes 1, 2, and 3. And there's a link to that as well down at the bottom. So here are some of the sources that it calculates. I just pulled some of the common ones. So for scope 1, there's 2 sort of categories that they sum up to. So stationary and mobile. So stationary would be anything that stays still, it does not move. So that'd be most likely natural gas. And then mobile sources would be stuff that moves. So any company-owned vehicles, gasoline and diesel would fall under that category. And then I've listed some of the other ones. But the great thing about this is that it walks you through every step that you would need to calculate your inventory or your baseline. So the boundary, unit conversions, the emission factors. So the EPA is a great source of emission factors. They're already built into the calculator, so you know that they're both reputable and they'll be calculated correctly. And then there's a help source or a help tab for each source. So if you have a question, I'm not really sure how to fill this out, let me go look at the help tab. It's really meant for people who don't have a super great background of emissions accounting to fill it out, and it's very, very user friendly. So I have a couple of screenshots to show you. So this is the summary tab. So we've got scope 1 and 2, and then scope 3 just cut off at the bottom below this. And you can see, you can, if you look at your stationary combustion number, you're like, that doesn't really look right. That looks way too high. There's a hyperlink that you can go to that sheet and then back. So it's very user friendly. It also calculates both location-based and market-based. And then it also gives you total numbers at the bottom. So see how it says scope 1 and location-based scope 2 and scope 1 and market-based scope 2. So that's how you would report out those numbers. So here's a screenshot of the scope 1 stationary combustion sources. So this would be the natural gas. There's an example line on each tab, so you can see how the EPA is filling it out. So if you have any sort of questions, you'll be able to see like, oh, that's where I'm supposed to put what fuel it is. And they have a drop-down list of all the fuels that you can choose from for the calculator. And then here is the scope 2 one. So you can see there's location-based, and this is the EGrid. So this would be how it calculates your emissions based off of grid averages. So there's a calculate or a link that it'll take you. You type in your zip code so you can find out what subregion you are to type in that box, or it's a drop down. Okay, so just to review again, I have my nice little diagram here. There are 3 scopes of emissions. So scope 1 is direct, that's company facilities and any company vehicles. And the largest category within that is going to be natural gas. For scope 2, that's indirect, and most of the time that's only going to be electric power. And then scope 3 is everything else. So there's 15 categories of that, and it's broken up into upstream, which is the manufactured product and above, and downstream, which is after the product is manufactured. So end of use of life, end treatment, lease asset franchises, those types of things. So a couple of best practices for calculating your inventory, your baseline, is understanding what your methods are. So that's how you're going to estimate your emissions and what your emission factors are. The next one would be develop a data quality plan. So what numbers are you going to check? What are your, I don't think that looks right. Those types of things. The next one would be the process. So that's the order of operations. Are you going to ask for utility bills first? Who are you going to get that from? How are you going to gather that data? And the last thing is write it down. Write every single thing down, because you may do something today and think, you've got a solid process. And then in a year from now, when it's time to calculate your baseline or your inventory again, you may have forgotten. So write it down, write it down, write it down. And with that, I will open up the floor for some questions. Do we have any questions?
I'm not seeing any come in. So if you want to go ahead and move on to the poll.
Yeah, that's fine.
You can also type in questions as they're polling too. Yep. And I'll keep an eye out.
Sounds good. So I think
all right, folks, again,
right?
This question is, how many scopes of emission are there? 1, 2, 3, or 4? All right, and it looks like everyone has answered.
Awesome, and everyone got it right. So yeah, there are 3 scopes of emissions.
And this question is, what scope does natural gas fall under? Scope 1, 2, 3, or 4? We'll give about 30 more seconds to answer. All right, we will close out this poll.
Okay, so it looks like there was a little confusion on that one. So let me pull up my review slide. So natural gas is going to be scope 1. So that's scope 1 because those emissions are being released from your facility. So that natural gas is burned to create heat for a boiler or for the building at your facility. So that is going to be directly released into the atmosphere at your facility. So that's what scope 1 is. The thing that makes it different from scope 2 is, so for electricity, which is scope 2, those emissions are being burned at the power plant, which is outside of your facility, but the electricity is being consumed at your facility. So it's being released into the atmosphere at another facility, not your facility. So does that make sense? You can definitely email me if you have more questions about that. It's very tricky. Okay.
And Samantha, the only question that we've got is actually about the slides, because your slides are phenomenal. Don't worry, everyone. You will be getting a copy of all the slides. It'll probably be tomorrow, along with a recording of the webinar. Okay, so just want to make sure everyone knows that.
Okay, so if there are no more questions, I will introduce my colleague, Mark Toda. And while he is sharing his screen, we can go ahead and do his poll questions as well.
All right, so our first poll question is, how can I reduce my carbon footprint? Your options are improve energy efficiency, reduce supplier logistics mileage, renewable energy, or all of the above? We'll give you about 30 seconds. All right, we are going to close out the poll. And we have another question as well. This question is, what is one way of reducing emissions from transportation logistics? Increase fuel efficiency, reduce miles driven, reduce use of diesel-powered vehicles, or all of the above. About 40 seconds. All right, everybody has answered that question mark, so you can go on ahead and get started.
Okay, thank you very much, Lindsay. Can you see my slides okay, Lindsay?
Yes, sir, you did perfectly.
Okay, wonderful, very good. Well, good morning, everyone. Again, my name is Mark Choda, and I'm a senior engineer at the Kentucky Pollution Prevention Center. Samantha already described to you what we do, so I'm going to just jump right into my presentation here. And just want to encourage you all that if there's any way that we can be helpful to you, please don't hesitate to contact Samantha or myself. We'd be more than glad to help. That's what we're here for. We are supported by the state of Pennsylvania and through federal funds through EPA to be of assistance to business and industry here in Kentucky. So please feel free to contact us. So what I'm going to be talking about today is, okay, we found out from Samantha what greenhouse, and from Robin really, what greenhouse gas emissions are. And so the question is, how do we reduce them? And that's really what the focus of my presentation is going to be on today. Because this series of webinars is really related to the automotive industry, although my presentation today is just a general presentation on reducing greenhouse gas emissions, so it's applicable to any type of organization. I want to talk a little bit about some of the big three automotive manufacturers and their interest in carbon reduction, because all three of them are focused on it. So from a Ford perspective, they're interested in achieving carbon neutrality by 2050 and using 100% local renewable electricity in manufacturing. So these are two goals that they have. And what does carbon neutrality mean? What carbon neutrality means is that the amount of greenhouse gas emissions, the amount of CO2 emissions equals the amount of CO2 that's removed. So the amount you put into the atmosphere, you're going to remove that same amount from the atmosphere. And there are carbon capture technologies that actually do that removal function. But if I can reduce the amount of emissions that I'm putting out into the atmosphere, if I'm going to get carbon neutrality, that's that much less carbon emissions that I have to remove from the atmosphere in order to achieve carbon neutrality. These are terms that are used quite frequently: carbon neutral or net zero carbon, which is basically the same thing. But these are terms that are used quite often, but oftentimes the layperson doesn't really understand what they mean. So I wanted to mention what that actually means. If you Google Toda's environmental challenge, you'll be able to see They have a 2050 environmental challenge. And there's actually 6 challenges. The 3 of them that relate to carbon are, first of all, reducing CO2 in vehicle design, in designing of vehicles. So they're focused on that. They're focused on reducing CO2 in their supplier operations, manufacturers or businesses that supply to Toyota. And then finally, they're focused on reducing CO2 emissions in Toyota operations itself. So those are 3 areas that relate to carbon for Toyota. As far as General Motors is concerned, these are things they're focused on, again, carbon neutrality in products and operations by 2040, 100% renewable electricity in the US by 2030, and reducing operational energy intensity by 35% by 2035. And so you can see that again, they're focused on carbon neutral and renewable electricity here with General Motors. So anyway, with that as sort of an introduction, how are we going to do this as an organization? And the first thing that I want to just mention, just briefly here on one slide, is taking an organizational approach to doing this. In any business, there's going to be many employees, so there's many people that are involved with energy consumption and the resulting greenhouse gas emissions. So we need to get everybody on board with doing this, and it begins obviously with upper level management support and commitment. Reducing greenhouse gas emissions needs to become a mainstream business function, and it really is becoming more and more of a mainstream business function in most businesses today. When I was younger, we weren't even talking about sustainability, and now we are, and now environmental sustainability has become a mainstream business function within most organizations. If it isn't, then it'll be good for your organization to move towards that and to try to understand how can you incorporate that as a mainstream business function. Create an energy and emissions team. So there needs to be a team of people, typically a cross-functional team, that will actually be addressing this issue, because there are many other people in the organization, have lots of things that they're busy doing. And so there needs to be a team of people that are focused in this area. And then lastly, communicate and motivate all employees. In other words, there needs to be a policy around greenhouse gas emissions. There needs to be specific goals and objectives that everybody knows this is what we're shooting for. And then finally, there needs to be training. Employees need to be trained so that they have the information they need to be able to help in the process of reducing greenhouse gas emissions. So Toyota has provided what they call green supplier requirements. These are requirements if you're going to be a supplier to Toyota. First of all, compliance, obviously, with environmental laws and regulations. And typically they are looking for the ISO 14001 certified. ISO 14001 is a environmental management standard. One of the things that Toyota is looking for is a reduction in, this is for the supplier facility operations. As Samantha mentioned, that we're talking now scope 1 emissions. Well, let me correct that. As a supplier, I'm going to have scope 1, 2, and 3 emissions. Okay, and so what Toyota is looking for from supplier facility operations is, first of all, that suppliers maintain a tracking of electricity, natural gas use, and CO2 emissions. And so this goes back to what Samantha was referring to as far as documenting, is collecting data and documenting data use. So these are 3 areas that need to be tracked and documented on a monthly basis. Secondly, they're asking for suppliers to pursue opportunities to reduce energy use and CO2 emissions and to consider renewable energy options. And then finally, they're looking for suppliers to set a minimum target of 2% CO2 emissions reduction per year. So that's the target right there that we're looking for is 2% of CO2 emissions reductions per year. And so that will be a great goal to have for your company, or a great objective to have for your company. When we look at from logistics supplier activities like trucking, transportation, and things like that, Toyota is looking for suppliers to maintain a tracking of fuel consumption, distance traveled, and fuel efficiency. They want suppliers to assist them in the best available alternative transport technologies and help to pilot these technologies. And again, they give a target here: reduce absolute CO2 emissions from these logistics activities by 15% by fiscal year 2026. And that's from a 2018 baseline. So again, it's about 1.9% per year. So again, the target that they're looking for is again about 2% per year. And so if 2% per year is about 10% in 5 years. So that's kind of what we're targeting, and as suppliers, something that we should target. And if you're not in the automotive industry, that's fine. These are actually relatively good targets for just about any company to be going after. But anyway, I'm just bringing this up, the automotive, as an example. So back to kind of tying this together with Samantha's presentation. Again, we have scope 1 emissions, and as Samantha identified, it's from company-owned vehicles, and it's natural gas used for manufacturing used at the facility. So this is natural gas that's burned on site, or company-owned vehicles that combust fuels. Typically, that's going to be gasoline or diesel vehicles. We're also going to have scope 2 emissions. As a supplier, I'm going to have scope 2 emissions, and that's basically my purchased electricity is the biggest one, that, or the most common one, scope 2 emissions that folks will have. But I'm also going to have scope 3 emissions, and this is from upstream and downstream supplier activities. You know, companies that supply to me, and then as I deliver my product, I'm going to have scope 3 emissions potentially there as well. There's going to be travel, transportation in regard to that, and various things. So it's downstream and upstream supplier activities. These are all 3 scopes, are things that I should be tracking on a regular basis and be concerned about. And again, calculating them to the best of our ability, and collecting data that makes sense, that I can collect on a regular basis, and then I can then calculate my emissions from on a regular basis. So energy reduction. If I'm going to reduce greenhouse gas emissions, I want to reduce energy. Okay, so a change in energy use is going to relate to a change in emissions. And I can reduce energy in 2 ways. Energy is really, for electricity, it's typically kilowatt hours. It's the kilowatts, which is my electric demand. If I have a 100-watt light bulb, that's 100 watts of demand. And how long I keep it on is going to equal how much energy is required there. So I'm looking at demand and time. Those are the only 2 things that I can change. So either I can reduce down to a 50-watt light bulb, or I can reduce the amount of time I have that light bulb on. Those are my 2 things. So reducing kilowatts is going to mean an equipment change, and reducing time is a process change. In other words, I have to turn the lights off, or I have to put an occupancy sensor on that light, something to reduce the time. Natural gas is the same thing. I have BTUs per hour, And then I have the number of hours that the natural gas device is on. And so it's, again, I can change my BTUs per hour. I could get a smaller furnace if I'm heating a facility, or I can reduce the time that furnace is turned on. So these are, when it comes right down to it, these are the two things that I can do to reduce my energy use. So the emissions then obviously are going to be the kilowatt hours times the emission factor that Samantha had mentioned in her presentation. So the three main areas that I wanted to talk about today as far as reducing greenhouse gas emissions is first and foremost energy efficiency. We want to reduce the amount of energy that we're using at our facility. And in this, we want to reduce wasted energy. In other words, if I'm just using energy and it's not doing me any good, that's wasted energy use. We want to reduce that first. Second thing is renewable energy. I want to be able to use renewable energy where possible. As you can see, the OEM automotive suppliers are focused on renewable energy. That's important. And then thirdly is transportation and logistics. These are three areas that I can focus on to reduce greenhouse gas emissions. So the first thing is, again, data tracking. We want to be able to track our electricity use, natural gas, gasoline, diesel, and how many miles we drive our vehicles each year. So we need to have good data integrity here as far as what we're currently using. And then we want to sum those to get an annual total for each year in each of these different areas. And then from those numbers, calculate the scope 1, 2, and 3 greenhouse gas emissions. So this is, I'm kind of sort of demystifying this whole process of greenhouse gas emissions. This is data that I can get, and I can add it up for 12 months to get the annual totals. And we know what we can figure out what the emission factors are, so we can actually calculate what these greenhouse gas emissions are. It's a known quantity. So as far as energy efficiency is concerned, these are things that if you haven't done them yet, these are things to be focused on. First of all is lighting. Lighting retrofits with LED lights, the wattage is lower. So that's going to reduce my energy cost there. That's going to reduce my energy use. Light levels can be reduced. Oftentimes we go into facilities and the light levels are way higher than what's needed. And so delamping of lights can reduce energy use. And then finally, just reduce the number of hours. We have one facility that they have their lights turned on 24 hours a day, 7 days a week, but yet they only have 2 shifts of operation. They just want to have the lights on all the time. You know, do they really need to do that? That's something that we need to examine. HVAC systems are something that we need to take a look at, looking at temperature setbacks, replacing inefficient systems, using variable speed drives on HVAC systems. These are all things that are doable to reduce energy use within the facility. Finally, compressed air. A lot of our manufacturers are using compressed air. And the first opportunity is to reduce pressure. For every 1%, there's a 1% energy reduction for every 2 PSI reduction in pressure. So that's significant. They're reducing the hours that our compressors are on. Some manufacturing operations may have only 1 or 2 shifts, but the compressor is left on for the 3rd shift when it's not needed to be on. And so it's going to be running, and and consuming energy, which is just really wasted energy. We want to do leak detection, looking at compressed air leaks and repairing those leaks. Because if I'm having leaks in my compressed air system, then I'm just using energy to create compressed air that's just going off into the air in my facility rather than being used for useful purposes. Replacing motors, looking to replace any inefficient motors or oversized motors. Oftentimes we may find motors that are used that are bigger than is what is needed, so they can be replaced. Reducing motor runtime, and again, using variable speed drives. Another area is process heating and cooling. Again, temperature setbacks in process heating and cooling, but you know, replacing inefficient systems. Well, I'm sorry, I have a typo here. This is my mistake. What I meant to put here in process heating and cooling is looking at insulating pipes and equipment to reduce heat loss with process heating and cooling, but also heat recovery are the two things I meant to put in here. So I apologize for that. That was a typographical error on my part. One of the things that we have been doing the last 3 or 4 years at KPPC is something which we call sustainable value stream mapping. And this is an example of a value stream. A value stream map is basically looking at the different manufacturing operations within a manufacturing facility, and then looking at the energy consumption in each particular operation. And so in this particular case, we're looking at motors and pumps in each operation. We also look at cooling systems, whether it be chillers or cooling towers, and which operations use that cooling water. And then compressed air use. Which operations are actually utilizing compressed air? And you can see that operations 2 and operations 4 are the biggest energy from electrical energy use perspective. We can also add natural gas to this as well. Which process steps actually use the most natural gas? And then this sort of sustainable value stream map helps me to target where can I reduce energy. And if you'd like help actually laying this out, we at KPPC would be glad to help you with this sustainable value stream mapping approach. From a natural gas perspective, we want to add natural gas to our sustainable value stream map and look at how many pounds per hour is required for each process step. And then again, how many hours is each process step. Looking at steam leaks, again, steam trap maintenance is important. Again, looking at steam pipe installation and heat recovery are opportunities to reduce natural gas use. I want to talk a little bit about renewable energy, and I set this up as just an example. We do have a Kentucky automotive supplier here, and this is all, not letting you know their name, this is all non-proprietary information, but let's suppose that I have a Kentucky automotive supplier that uses almost 1.4 million kilowatt hours a year of electricity. If they were to put in a 25 kilowatt solar system, okay, they would generate annually close to 34,000 kilowatt hours of electricity. So basically that would in a sense reduce the amount of purchased electricity required by this company by the 34,000 kilowatt hours. That's a 2.43% reduction in electric energy use. And if you remember, our target is 2%. And so this would be a pretty good contribution to getting to that 2% reduction. Again, let me clarify, the 2% reduction is for the company facilities, is for scope 1 and scope 2 emissions. So when you add those two emissions together, we want to reduce the total by 2%. So that's just to clarify that. And then the scope 3 emissions, we want to reduce those by 2% also. But this 25 kilowatt solar system is about a $37,000 investment, requires about 70 panels roughly. And you can see the size of the array there, basically 37 feet by 37 feet. So this is, I want to just sort of give an example here from, this is transportation basically here. So this is related to scope 3 emissions. And if I were on these first two lines here, I have one gasoline vehicle and one diesel truck. And I'm assuming I drive those two things 20,000 miles a year. Maybe it's going to be a lot more than that, but I just chose a number here, 20,000 miles driven per year. I have the fuel efficiency there, 25 miles per gallon for the vehicle, for the car, and 15 for the diesel truck. And so based on that, I can determine how many gallons of gasoline I've used that year. And I have the cost for gasoline and diesel there. And so I have an annual fuel cost. So for those two vehicles, it's $6,880 is the total annual fuel cost. Gasoline has an emission factor of 8.78, whereas the diesel has a higher emission factor. So it's higher CO2 per gallon of 10.21. So I can calculate my CO2 emissions, just taking the emission factor times the number of gallons, and then I can convert that to metric tons. So I have 20.64 metric tons. If I multiply that by 10, if I have a fleet of vehicles now, gasoline and 10 gasoline vehicles and 10 diesel trucks, now my total is 206 metric tons of CO2 emissions. So let's say that I somehow I was able to reduce my diesel truck mileage down to 18,000, and I increased my gasoline vehicles by 2,000 to 22,000. Maybe I'm delivering some things with diesel trucks when I really could deliver them probably with a gasoline car. And this is just one way of reducing gallons. But you can see that multiplying this out, I have actually spent the same amount of money in fuel costs, just slightly more in fuel costs here. But I have reduced my emissions from 206 down to 199, roughly 200. So I've reduced it by 6 metric tons, which is a 3% reduction in greenhouse gas emissions. Now, this is only one way to approach this. I mean, reducing, I can get more efficient, fuel efficient vehicles. So I can increase my miles per gallon from my vehicles to maybe from 25 to 30 miles per gallon or higher. Another thing I can do is I could, again, focus on my miles driven. You know, oftentimes as a driver, we'll drive cars for the quickest time. But maybe we need to start thinking about the shortest mileage instead of the shortest time. And so these are things that again, lots of different ways to approach this, but this is why employees need to be educated on what the goals are so that they can do their function and their operation in the most efficient way from a CO2 emissions perspective. So we can increase, again, fuel efficiency. We can be focused on optimal route rather than just the shortest time. And we can, again, reduce the use of diesel vehicles. These are 3 potential ways. And I think there are other ones in addition, but these are example ways of reducing scope 3 greenhouse gas emissions. So that's all that I have for today. I think I'm just about out of time here. But please, if you want to learn more about KPPC, please visit our website at kppc.org. We do have a lot of resources there that can be utilized. Both Samantha and my contact information is there under our staff resources. So feel free to visit our website. And I think we have our first poll question up.
Yeah, we have our poll question again. So the question is, how can I reduce my carbon footprint? And your options are improve energy efficiency, reduce supplier logistics mileage, renewable energy, or all of the above. We have almost everyone who's answered, but we'll give about 20 seconds more just in case.
I think my question was too easy, Lindsay.
I think so. I think everybody else expected more. They really upped the ante. All right, let's end this poll and then we'll share the result. Everyone did very well. And we will launch that second poll. All right, again, your question is, what is one way of reducing emissions from transportation logistics? And your options are increase fuel efficiency, reduce miles driven, reduce use of diesel-powered vehicles, or all of the above. And we have about 6 of the 8 people who have answered so far, 7, very nice. We'll give it just a few more seconds, but I think everyone did very well. All right, let's share those answers with everybody. How'd they do, Mark?
I think they did pretty well. I guess.
Wonderful, then we will turn everything back over to Robin for her closing remarks.
Thanks, Lindsay. We are actually 30 minutes early. So thank you guys for everything today. Give a big round of applause to Mark and Samantha. They did wonderful presentations. And like I mentioned earlier, attendees will be getting the presentations probably tomorrow via email. Same thing with a link to the webinar itself. I also noted a couple documents that we've created over the past year or two that I think everyone might find useful. We have an energy team, BMP guide, and then a sustainable value stream mapping BMP guide that I'm going to attach and send to everyone. You will also be getting, probably in about an hour or so, an evaluation survey for this event. Please take 5 minutes and complete it. Give us your comments, ideas, any feedback is greatly appreciated. We will be doing 2 more different webinars in this series. They'll both be in September. They are automotive sector specific, but everyone is welcome to attend that. So if you would like to go ahead and register for that, just go to dca.ticketleap.com. You can register for both or just one of those webinars. And I'll send that information in the email later too. Please feel free to contact myself or Samantha or Mark Toda with any questions that you have. I'll include everyone's contact information in the email. And both of us, KPPC and Kentucky Excel, do have newsletters and blogs. So if you would like to be added to that, just send me an email. If you want to participate in KPPC's, was it sustainability posts? Is that right, Samantha, Mark?
Sustainable Solutions posts.
There you go. Just go ahead and send it to me and I'll forward that information onto them, or you can email them directly, of course, and then mine is green moments. So thank you for attending. Mark, Samantha, did you have any last words that you would like to say?
Nope, I think you wrapped it up well, Robin. If there's any
All right.
questions, reach out.
Yeah, thank you guys.